Hey guys, look at what I have here, my new upgraded I2C Controllable buck boost converter, which we can control with any MCU you want. So let's immediately talk about the various changes and additions I made. The first one, I added M2 mounting holes so that now the PCB doesn't touch the surface you are working on. We have a little bit more room for the heat to escape. I've also embedded the two I2C resistor into the board so that now you can directly connect the wires without external I2C resistors as we did with the previous version. And I also tried to make the various labels clearer, and you can see now I added the label for the input voltage range, and up there the I2C addresses are now visible on the PCB. But two big additions are the current sense resistor here and this 2-channel SMD dip switch to change the frequency of our converter. And we're going to see those in a few minutes, but first let me do a size comparison between the old and the new version of the board. And you can see that while the horizontal length is almost the same, the vertical length of the new board is a little bit longer. Nothing too critical. Anyway, if you want to support me, you can leave a like and subscribe or buy me a coffee. Now to test my converter, I've designed this interface here, which is basically the one I've used with the LM51772, just with less features. And while the interface looks clean, the code is absolute garbage. Okay guys, as you can see we have 0 volts at the output now, and of course if we click enable, well, we enable the converter. We can modify the voltage using the voltage menu. So let's do 3.3 volt. There we go. And we can cycle through the various voltages here, for example 5 volt, 9 volt and 12 volt, the standard voltages you want. And we can modify the voltages in 10 millivolt steps. As you can see here, you have 10 millivolt. It responds quite well, as you can see. I also added a 100 millivolt step and 1 volt step just to do things faster. As you can see, it works. Let's use the keyboard here to input a voltage, for example 18.39 volt. Let's enter. There we go, pretty spot on, as you can see. Let's do another value so you can see it was not a fluke. There we go, 16.08 volt. And this time guys, we can also control current. And as power resistors, I'm using the best power resistors in the market, which are AliExpress cables. So let's enable the converter, and as you can see we have a 6.36 amp of current flowing through our load. And well, you may think, well, that's too high, so let's go into the current menu and enable the control current mode. And now we have 1 amp of current flowing through our load, and we can control this in 100 milliamp steps. I added now 100 milliamps, so we have 1.1 amp. Really, the implementation is up to you. You can use encoders, push buttons, really whatever you want. I've chosen a graphic interface because it was the simplest way to show to you those things. Yeah, but it works really good. And that's all. So let's now talk about another feature. We have 5 volts at the output, and I'm going to draw 1 amp of current. There we go. Now we have 4.97 volts at the output. Here it comes the CDC compensation or cable drop compensation feature, which basically rises the voltage for every amp that we draw. So at 50 millivolt, we should get 50 millivolt more for every amp, and that's true, okay. But now if I rise it again, as you can see, for some reason it doesn't work really well because I get only 20 millivolt more. Now I should get 5.09, instead I get 5.08, that's still good. And now it's working pretty good. As you can see, the voltage is rising for every amp that I draw. And well, at 7 amp we have 5.29 volt. Another great feature is this one. You can see the voltage is going down because we disabled the converter, and if we click discharge, the output immediately goes to 0 by an internal 100 milliamp current sink. Now, what about the frequency switch here? Well, basically we have four possible switching frequencies: 200 kHz, 400 kHz, 600 kHz, and 800 kHz. And sometimes choosing a different switching frequency leads to greater efficiency, but in general you won't find yourself changing the frequency very often. I mean, you can use the converter without touching the frequency settings. Let's say it's here just as an added feature. As a last, let's do a quick summary of the features of the converter. We saw that the input voltage can vary between 3 volt and 30 volt, the output from 0.9 to a little more than 21 volt in 10 millivolt steps. The output current of the converter can reach 6 amps or 7 amps for a brief period of time. We have the control current in 100 milliamp steps, the CTC compensation feature, and the discharge feature. Now that we saw those features, let's see how to program the board in the Arduino IDE. But first, let me thank my sponsor PCBWay, who provided all the PCBs used in this video. PCBWay produces high-quality PCBs, and it's the perfect partner if you're into electronics, either if it is your first project or a really advanced one. And if your joints are like mine, or you don't want to waste time on soldering, well, they can also assemble PCBs for you. Not only that, they also offer 3D printing and CNC machining, with really tons of materials you can choose. Just check PCBway.com, link in the description. The last time we saw how to program the board, we only used the wire library, but this time I've made a bit of a progress because I'm developing an Arduino library that I will upload on my GitHub profile those days. So let me show you an example you can find on the library. This one uses the serial monitor to change the voltage. You can write any raw value from 0 to 2047 and you're gonna see the voltage changing accordingly. This is achieved by using the set voltage raw function, but you can also write the voltage in millivolt using the set voltage function. And to change the current, we can do the same thing. Again, we have two functions. We can set the current using the set current row or just the set current. Anyway, you will find all the functions and examples on GitHub. Just give me some time to write and upload all the codes. If you want to buy the converter, you can find it on the shared project of PCBWay. But I don't exclude in the future I will do a crowdfunding for it. Anyway, hope you enjoyed. Subscribe and see you next time. Bye.